Hello class 12. Today we will try to do electric field of an electric dipole. In the last class we have done electric field due to a single point charge. So for today we will have to do electric field of an electric dipole, okay? And this can be done in two ways. At a point on its axial line, that means the line joining these two equivalent opposite charges, we call it this line as an axial line. So just to find out electric field at any point on its axial line, that is the first one. The second one is to find the electric field due to this electric dipole on its equatorial line. Equatorial line means a line drawn perpendicular to its middle point of the electric dipole. We call it that as equatorial line. So the first one is what? To find electric field at a point on its axial line. That is the first one. So let's take it an electric dipole, okay? Minus q plus q represented by AB, of whose center or the middle point of dipole is at O, and the length of a dipole we generally denote it by what? Twice L. But here in my diagram I have written only L. So it should be what? Twice L should be there, okay? Twice L it should be. Got it? Yes. Now what happened? Let the point of observation P be at a distance r from the center of this dipole. At this point we need to find out the electric field due to this dipole, minus q and plus q, right? Yes. Electric field intensity due to minus q at P is, at this point P, electric field due to this charge will be equal to what? We know that electric field intensity or electric field simply due to a single point charge is equal to what? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Let me remind you. 1 by 4 pi epsilon naught into what? Magnitude of charge, let me denote it by q, divided by distance square, right? Like this, no? So for us also here, due to this minus q charge at this point P, we have to assume that this is the only charge, okay, residing in the vicinity of this point P. So while taking like that, as this is due to the negative charge, let me represent the electric field by E vector minus for negative q, okay? So will be equal to 1 by 4 pi epsilon naught magnitude of the charge here and the distance square, AP square, right? Is equal to what? 1 by 4 pi epsilon naught q same. AP means what? This distance from here to here is L, from here to here is L, so that the length of the dipole in total it will be twice L. So we can write this AP as R plus L. So instead of that AP square we can write as R plus L whole square for this square, and the direction of the electric field will be along PA because this is a negative charge, and if you assume that there is a test charge here Q naught, okay, then that test charge will be attracted because test charge is always positive and this is negative, so it will be attracted toward the negative charge. So the direction of the electric field E vector minus will be acting along this PA. That is what I'm writing here. And electric field intensity due to plus q at P is what? Similar to this, it will be equal to what? 1 by 4 pi epsilon naught here q, for this q plus q you have to take it only the magnitude, okay, here. So this will be also plus q, and the distance between this charge and the point of observation is bp square. So you have to write bp square. So bp means what? From r, if you subtract this much l, then you will get bp. From op, if you subtract this ob, then you will get what? Your bp. So your op is what? R. ob is what? L. So from r, if you subtract this much l, okay, if you subtract this much l, then you will get what? bp. So bp square, right? Yes. Yes, electric field intensity of a dipole is what? You have to do the superposition of E minus vector and E plus vector, and in that superposition we have to simply add, and in that what happened, this is a vector quantity, so what happened, there will be direction. The direction will be along the direction of the bigger vector if you do that vector addition, okay? Yes, 1 by 4 pi epsilon naught times q, that will remain same, and for that of the minus it is r minus l whole square, and for that of the e plus it will be equal to what? R. Let me see the next slide first, okay? Yes, this is what? E minus is what? 1 by 4 pi epsilon naught q r plus l whole square along PA, that means along this PA. And for E plus 1 by 4 pi epsilon naught q, this portion is same, 1 by 4 pi epsilon naught times q. Here in E plus is also 1 by 4 pi epsilon naught times q. For E minus also 1 by 4 pi epsilon naught times q is there. And this is r plus l square. For minus E minus it will be r plus l square. For E plus it will be r minus l square. So we need to add these two, okay? So let's see. Now electric field intensity of the dipole is what? E is equal to E vector equal to E vector minus plus of E vector plus, right? This will be equal to what? 1 by 4 pi epsilon naught times q whole into what? 1 by r minus l whole square minus of r plus l square. Why we are taking minus here? Because the magnitude is more by what? The magnitude is more by that of E plus, because it is closer to what? A point of observation. So your B plus is closer to the point of observation, and naturally there will be stronger force of repulsion between these two instead of the farther one, the attractive force. So this one for E plus is having more stronger force than a stronger field than that of E minus, and moreover the direction of E plus is along what? OP, or rather you can call it as BP also, from B to P for E plus. For E minus it is from P to A, okay? So as the direction are opposite, when we add two vector quantity of whose direction are opposite, naturally in magnitude we have to subtract it, and the direction of that vector will be along the direction of the bigger vector. So what happened? You have to subtract it these two, because this one is more for that of E plus and this is for E minus, okay? If you do this, then you will get in this way, taking the LCM of these two, then you have to do it, okay? So r plus l, right, whole square minus of r minus l whole square, like this. So you will get it in this, like this. So after doing the simplification, it comes out in this way. E is equal to 1 by 4 pi epsilon naught twice p r, p vector r divided by r square minus l square whole square. From where this p vector is coming, this is nothing but this is a dipole moment, and dipole moment is equal to twice what? The length of a dipole. Okay, twice L means the length of a dipole times either of the magnitude of the charge. So twice L times Q is equal to what? Dipole moment P, and it is directing from minus Q charge to plus Q charge, right? We have done this in the previous class. Now we are getting like this. So what happened? Your dipole moment is also acting from minus q to plus q, and your E vector will be also acting from minus q to plus q. So they are of the same direction, so no need of putting any sign here. This represents what? E vector is equal to what? The direction, I mean E vector and P vector are along the same line. So we can simply write like this, right? Now let's see some condition. If your distance of observation from the middle point of the dipole is very much greater than the dipole length, that means if your this point of observation, if it is very far away, okay, if this r is very large than this twice L, when you compare this r and twice L, if this r is very much greater, naturally your point of observation must be very far away from the center of the middle this dipole. So what happened in that condition? From this resulting equation, the last equation, I mean this one, and when you subtract these two, this is very small but this is very large, so this small is immaterial, as if there is no subtraction of this L square, right? So we can approximately say that only r square whole square. So r square of square means what? It will be r to the power 4. So one r and another r, if you cancel it, then you will get it what? In the denominator as r cube. So twice p vector r cube will only remains. This 1 by 4 pi epsilon naught will be there, no doubt. So what happened? This is the ultimate what? Expression of electric field E due to a single due to an electric dipole on its axial line at a distance r from the middle point of a dipole. Now let's see what it can be noted from this expression. Your E vector is along P vector, that, as I have said, of same direction. This to be noted, okay, in the case of an axial line. And moreover, the magnitude of electric field due to an electric dipole is directly proportional to 1 by r cube, or you can say that magnitude of electric field is inversely proportional to cube of the distance of the point of observation from the center of the dipole. But in the case of a single point charge, what happened? The direction, the magnitude of electric field is what? 1 by r square. 1 by r square. This is for a single point charge, okay? Electric field E for single point charge is what? E is inversely proportional to r square. But in the case of electric dipole, E is inversely proportional to r cube. So what happened when an electric in a single point charge, electric field due to a single point charge decreases as the point of observation goes on outward. That means if r increases, electric field E decreases in the case of single point charge, and here also electric field E decreases when the distance r increases, but the rapidity of decrease in the case of electric dipole is more than that of a single point charge, because in the denominator cube is there for dipole, and that of the single point charge is only what? R square in the denominator. right? So let's do up to this for today.